everyone, and welcome to today's session. Let me introduce myself. Rakshit Parikh, and a lecturer in the Mechanical Department, Parul University. On behalf of the Mechanical Department, first of all, I would like to thanks to our today's speaker, Mr. Amit sir, so for accepting our invitations and spend their valuable time and sharing their knowledge on the today's topic, that is the post combustion carbon capture technology. So now I would introduce our today's speaker, Mr. Ajit Kumar sir. Sir has completed his graduation in mechanical uh, engineering field, and also completed a post graduation in thermal engineering, and completed his postdoctoral degree from the IIT Delhi. And sir has a 14 plus years of experience in the field of the teaching and also in the research area. Sir published his international journals, around 11 plus publications, and also published a national also published their research paper in the national and international conference, around 10 or 4 paper. And now sir has working as a assistant professor at the IIT RAM College Ahmedabad. And and our topic was post combustion carbon capture technology. As we know nowadays, there are lots of global warming issues and climate changes, and most probably you also aware about the reasons for the global warming and the climate changes. And one of the reasons, that is the carbon content after the completion, after the combustion. Okay, so nowadays, as you know, in a bike also there is some new engine modification. There is a BS6. Okay, BS4 or BS5 already departed by the governments, and now we can use as a BS6 engine. And the reasons behind use the BS6 for the reduce the carbon content from the atmosphere. Okay, after combustion, the carbon should be released from the combustion, so it should be reduced. So how it can be reduced? Okay, that should be taught by our today's speaker in today's session. So now I would introduce. I would like to say something about our today's speaker through our HOD ma'am. So please, Bindi ma'am, say something.
Uh, Good afternoon, everyone. Good afternoon, sir, Ajit sir. On behalf of Parul University, we heartily welcome you, and we are very privileged that we have invited you, and you have accepted our invitation to share your knowledge with our students. So, on
Thank you.
behalf of all the fraternity of Parul University, once again welcome you, sir.
Thank you. Thank you very much.
Thanks.
So, I begin.
Yes, sir. You can continue today's session, sir.
Okay. Could you remove your presentation so that I can present myself?
Yes, sir. Okay.
No, it's not coming actually. Just a minute. Okay. It's not coming actually. I'm just disconnecting it and then reconnect. Okay. I'm
Okay, sir.
disconnecting and reconnecting.
Okay, sir. Sir, your mic should be turned on. Right now it is off, sir.
Yeah, it shows that you need permission to screen your share. Is there any permission required?
No, sir.
No, it says that you must grant permission in order to screen share.
Actually,
can you do that?
Just a minute, sir. Actually, sir, you have to join through the ID which you mailed in for the connection purpose.
Yeah, I have joined through that ID only. But when I'm going to present, it says that can't share your screen. You must grant permission in order to screen share.
Good afternoon, sir.
Just a minute, sir.
Yeah, it's coming. Yeah.
Okay, sir.
Is my PPT visible?
Yes, sir. Now it is visible, sir. Yes, sir, it is visible.
Okay. Yeah. Thank you. So first of all, thanks to the organizing committee of this webinar for inviting me here to present my topic. The topic of my presentation is post-combustion carbon capture technology. I am the department coordinator and assistant professor in the Mechanical and Aerospace Engineering Department of IIT Ram. So to begin with, because most of you are not being aware of this topic, the carbon capture. So the few slides are of the introduction, and then I will present what we are doing at IIT Ram. So we all know that the carbon dioxide gas is called a greenhouse gas, and it is causing the global warming, and there are other problems that are associated with the carbon dioxide. So therefore, we must reduce the carbon dioxide, right? So the emissions from the carbon dioxide arises from the number of sources, mainly fossil fuel combustion in the power generation, industrial, residential, and transport sector. So the carbon dioxide are generated by there are two categories of by which the power that this carbon dioxide will be generated. One is the natural generation, and another one is the man-made generation. So the natural generation are those like we are taking the oxygen, we are inhaling the oxygen, and we are exhaling the carbon dioxide. So because of our respiration process, or the not ours, but also the animals, other animals also having this respiration process where they will take oxygen and exhaling the carbon dioxide to the atmosphere. So this is the one source that generate the carbon dioxide. The other source is man-made sources, like we are combusting the fossil fuels, right? We are combusting the fossil fuels like coal, in the power plants, diesel, petrol, in the automobile sectors, in industrial also, in an industrial sector also, like we are in the production of cement, uh, we are using the power, and where we combusting the coal, and that also generates the carbon dioxide. So how to reduce this carbon dioxide? We cannot do this anything with the natural generation of the carbon dioxide. We cannot stop breathing. That is not possible. So what is possible, that we could reduce the carbon dioxide by doing something into this man-made generation of the carbon dioxide. So carbon dioxide, as I said, that it is a greenhouse gas, and today the level of this carbon dioxide is too much. It is more than at any time in the last 8 lakh years. So the greenhouse effect, we all know that it is actually the global warming which is happening, and the process is called as greenhouse effect, and it is associated with the well-defined law. The law is the Wien's displacement law. Probably you are aware of this law. What is this Wien's displacement law? The Wien's displacement law is nothing but it is the product of wavelength multiplied by temperature is equal to constant. So it means what? It means that at high temperature, the radiations are emitted at a shorter wavelength side, and at the low temperature, the radiations are emitted at the longer wavelength side. So the sun, which is the main source of energy, it is generating the heat radiation. I mean, the sun is at being a very high temperature. It generates the radiation at a shorter wavelength side, and that radiations are reaches to our Earth. Right. So the carbon dioxide gas and other gases, other greenhouse gases, not only carbon dioxide, but also there are other gases which are also called as greenhouse gases, like methane. Okay, so there are many gases which has this greenhouse gas potential. So these gases allow the short wavelength radiations to enter into the atmosphere, right? And but when it reaches to the Earth's surface, the Earth will absorb these radiation, and then the temperature of the Earth will rise. And the Earth, because we know that if the temperature of the object, if it is above the absolute zero, then it will radiate the energy. So as the temperature of the Earth will rise, it will also radiate. But now the temperature of the Earth is it could be 40 or maybe 50 or not more than 60 or like that. So therefore the radiations that are coming out from the Earth are on the longer wavelength side. So what does this carbon dioxide gas and other greenhouse gases will do? This carbon dioxide and this greenhouse gases will now restrict these heat or radiation that are coming from the Earth, and it will not allow to escape from the atmosphere to the atmosphere back. So therefore this is what is called as heat trapping. So these greenhouse gases will trap the heat, and therefore the global temperature will rise. So what will we do? What can we do to slow this human-caused warming? How will we cope with the changes we have already set into motion? So the options that we had is we can switch the coal-based power plant or all the automobiles into the renewable energy side. Okay, like the solar power or the wind power or the fluid power. So we can do this, but it's not possible. I mean, the technology so developed in the renewable energy side are not so developed that we could switch all the power generation or all the automobile sector to this renewable energy. So we cannot do that. I mean, at least 50 years or 60 years or maybe a century will be required to develop such technology so that we can completely switch the coal base to the renewable energy sources. So what is the other option we have? I mean, therefore it means what? It means that we continue to use the coal for electricity generation. It will be our primary energy resources for at least 50 years or maybe 60 years from now. So the problem with the coal, as I already said, that it has it is generating the carbon dioxide. So if we will continue to use the coal for power generation, so the carbon dioxide gas, if you will exhaust the carbon dioxide gas into the atmosphere, so the emissions of from these fuels will continue to rise, and the results could be more devastating. So what is the option we have? So the options that we have that we will, capture the carbon dioxide before it exhausts to the atmosphere. So how can we capture? There are various solvents that are available which has a greater affinity to the carbon dioxide. Okay, so we can use the solvents so that, and we will pass the exhaust gas to the solvents, and then these solvents will absorb this carbon dioxide, and the remaining gas will be allowed to escape from this carbon capture unit. So carbon dioxide can be captured from large emission sources such as power generation and industry. Carbon capture and storage refer to the capture and disposal of CO2 released from the industrial process. So the term is called as CCS. The technique is called as CCS. CCS means what? Carbon capture and storage. Now, after capturing the carbon dioxide, what will we do for that carbon dioxide? We cannot, release the carbon dioxide back to the atmosphere because we are capturing it and we have to store it somewhere. So, or we will utilize it, right? So the process is called as carbon capture and storage. In the short, it is written as CCS. So with capture, we also have to think about the storage. The process is also referred as carbon sequestration. So carbon capture and storage are sometimes also called as carbon capture and sequestration, right? This carbon sequestration term is also referred to, also associated with the plants. The plants are also taking the carbon dioxide from the atmosphere, right? And it will convert this carbon dioxide into some organic compounds. The process is popularly called as photosynthesis, right? So these plants are actually a means to capture the carbon dioxide. So that carbon sequestration is termed as biological carbon sequestration, and this carbon sequestration or carbon capture and storage, it is termed as geological carbon capture and storage or sequestration. So as I said that after capturing the carbon dioxide, what will we do for this carbon dioxide? We will have to store it in somewhere. Okay, so where should we store so that it will not come out back to the atmosphere? So we have to find certain places. Normally it is stored deep into the earth. So we have to find some geological locations where we can store so that the carbon dioxide do not come back to the atmosphere. Okay, it could be onshore, it could be offshore. It doesn't mean that where we have captured the carbon dioxide, it will be stored right over there. Okay, because some structures are required so that if we are storing the carbon dioxide deep into the earth, it could not come back to the atmosphere. So these are some challenges which are there for the storage of this carbon dioxide. So one of the process where the carbon dioxide is stored, that process is called as structural trapping. So what is the structural trapping? In this structural trapping, we identify the location where you have some special kind of rocks which will act as a seal for this carbon dioxide. So these rocks are actually impermeable to this carbon dioxide. So carbon dioxide could not, pass through these rocks. So these rocks are acting as a seal. So what will you do? We will capture the carbon dioxide from the power generation plants or from other sources, and then we will, pressurize the carbon dioxide to a supercritical fluid. Why will we do pressurize? Because if we will pressurize it to a supercritical fluid, then what will happen? The volume of the carbon dioxide will be the manageable, so that it could be easily get stored deep into the earth. So we will convert the carbon dioxide into supercritical fluid, and then we will inject into the earth, down to the earth, right? And so what is the structural trapping? Structural trapping is the physical trapping of carbon dioxide in the rock. So we will actually inject the carbon dioxide deeper into the earth, and this, because of the buoyancy force, because this carbon dioxide it's a supercritical fluid, so it has a more buoyancy. Therefore, it will move up. Okay, so some rocks may permit this carbon dioxide to move up, but some rock may act as a seal for this carbon dioxide, so that the carbon dioxide will get stored over the years into this into this position, into this reservoir. So structure trapping is the physical trapping of CO2 in the rock and is the mechanism that traps the greatest amount of CO2. The rock layers and the falls within and above the storage formation where the CO2 is injected act as a seal. So the rocks, these are acting as a seals, preventing the carbon dioxide from moving out of the storage formation. Once injected, the supercritical CO2 can move buoyant than other fluids, other liquids present in the surrounding pore space. Therefore, the CO2 will migrate upwards to the porous rock until it reaches an impermeable layer. So we will inject it deeper into the earth, but there are some rocks which will permit the CO2 to move up, but is the rocks which they are impermeable to this carbon dioxide will act as a seal, and then further rising of the CO2 will not be possible, and the CO2 will get stored over the years in this structural trap. So this is the storage, but we can also utilize this carbon dioxide. We can utilize the carbon dioxide for the oil recovery. So what is this? This is what is called as enhanced oil recovery. In the short form, it is written as EOR. Okay, so what is this technique? In this technique, the carbon dioxide is injected into the earth where the production of the oil is taking place. So what will happen? This carbon dioxide is actually the oil is having a greater affinity toward the carbon dioxide, so therefore it will absorb the oil will absorb the carbon dioxide, and after absorbing the carbon dioxide, the pressure of the oil will get built up, and the oil could produce the oil in a larger quantity than previous. So according to data that is available, if you are using a normal procedure to get the oil from the mines, you could only recover 10 to 20% of the oil, right? But if you will use this technique, the enhanced oil recovery technique, so you could produce 40 to 50% more oil than the normal procedure, right? So this is the other way of the utilization of this carbon dioxide. There are other ways also to utilize the carbon dioxide, because in some industries the carbon dioxide are used for manufacturing. Okay, there is carbon manufacturing, carbon dioxide machining is also nowadays carbon dioxide machining is there. Carbon dioxide is also used in some industries, like particularly in the cold drink factories or in those production units. The carbon dioxide can be utilized. So carbon dioxide could be stored or could be utilized in various ways. So now coming to this carbon capture and sequestration as a process. There are three stages in this process. One is capturing the carbon dioxide and then transporting, because as I said that capturing the carbon dioxide and you cannot store right over there. You have to find some locations. The locations could be onshore or could be offshore. So first you capture the carbon dioxide from the power plant, and then what will you do? You will have to compress it, because you need to transport. The transport of carbon dioxide as a gas is very difficult, because the gas is having a high volume. So therefore, before transporting, you should compress the carbon dioxide, and then you have to inject and store it. So there are three processes: first the capturing, and then transporting, and then injecting. So now coming to the what are the various ways to capture the carbon dioxide from the fossil fuel power plants? So there are two ways. One is pre-combustion capture, and the one is the post-combustion capture. Now, what is pre-combustion capture? In the pre-combustion capture, the carbon dioxide is captured before combustion. Okay. So this process is generally we are doing in gasification of the coal. Right. So what is this gasification of the coal? The gasification of the coal is gasified, and you will get a gas which is called a synthesis gas. After gasification of the coal, you will get synthesis gas, and this synthesis gas has the constituents of carbon monoxide and hydrogen, right? So after this, you will supply the steam to this synthesis gas, and then you will get the carbon dioxide and the water vapor. Okay, then not carbon dioxide and the H2 hydrogen. So this carbon dioxide is now passed to some solvents so that the carbon dioxide will get captured over there, and the remaining hydrogen gas is used for power generation. Now, if this hydrogen gas is used for combined cycle power plant, and the process is termed as integrated gasification combined cycle power plant, that I will discuss in my later slide. The other procedure to capture the carbon dioxide is the post combustion capture. So in the post combustion capture, we are allowing the normal combustion of the fuel. Okay, and in the normal combustion of the fuel, we will get the flue gas, and this flue gas has many constituents. Okay, it has carbon oxide, it has nitrogen oxide, it has sulfur oxide, and so many things, right? So what will we do? We will now after normal combustion, we will pass the exhaust gas or the flue gas to some solvents which has affinity of the carbon dioxide only. Okay, so we will only use the solvent which has affinity of the carbon dioxide only. So the solvents will capture the carbon dioxide, and the remaining exhaust or the flue gas are allowed to escape from the power plant. So in this way, the carbon dioxide will get captured. The other method is oxy-fuel method. Now, in this method, we assume that the coal or the fuel that we are using do not have the other components other than the carbon and hydrogen, because the coal and other fuels mostly have the hydrocarbons, are made up of hydrocarbons, and there are some other constituents also. But if those constituents are negligible or neglected, then and if you supply only the oxygen for the combustion, then what will happen? If you supply only oxygen for the combustion, then the products that we will get from the combustion is only the CO2 and H2. So in this way, the CO2 can be easily captured, right? So I will discuss each method in detail. So the first method is pre-combustion capture. So this pre-combustion capture, as I told that in this, the carbon dioxide is captured prior to the combustion, right? So how it is done? It is done by in the gasification of the coal. So what is happening? We are supplying the coal or any other fuel in the gasifier, and we are heating up this gasifier to a certain temperature, and we supply the oxygen to a limited quantity. Okay, so how will we get this oxygen? We will get this oxygen from, because in the atmosphere we have the air, so we have to install one air separation unit which will take the air only, and because air is constituting air and nitrogen, so oxygen and nitrogen. So oxygen, we will separate the oxygen from the nitrogen, and we will take the oxygen into the gasifier, and after controlled combustion, we will the synthesis gas is formed. Okay, what is the synthesis gas? In the short, it is written as syngas. The synthesis gas has two constituents. One is carbon monoxide and the one is hydrogen. So this carbon monoxide and hydrogen synthesis gas is passed through the shift reactor. Now in this shift reactor, it contains some catalyst, and steam is passed through the shift reactor. So after this, you will get carbon dioxide and hydrogen. Okay, so this carbon dioxide is now passed through some chemicals, right, which has the affinity of the carbon dioxide. So this carbon dioxide will get captured over here, and then it is transported, and then it is stored at some geological site. The remaining hydrogen is passed to can be used as a fuel directly into the automobiles, or it can be used in a combined cycle power plant. So if it is used in a combined cycle power plant, the process is called as IGCC. Okay, what is this IGCC? In the IGCC, this gasification and the power generation will take place simultaneously. Okay, IGCC is the integrated gasification combined cycle power plant. So integrated gasification and combined cycle power plants are integrated. So what will happen in this? The hydrogen is passed through first gas turbine, and the gas turbine, the hydrogen is burnt in the presence of the air, and you will get the electricity, right? So the flue gas will get formed. In this flue gas, there is no carbon dioxide, but there are water vapor and the constituent of air like nitrogen. So there's some nitrogen oxide are also there. So this flue gas is then passed to the steam generator or a boiler. So this boiler will generate the steam, which will pass to the steam turbine, which again gives the electricity. So electricity, you will generate the electricity from this combined cycle power plant by using the hydrogen only. So this process is termed as IGCC, and it is it is implemented in various countries. this IGCC facilities are available at various countries. So it is being in use. So this is IGCC. IGCC is integrated gasification combined cycle. And what are the features of this? The features are that it involves converting the coal to carbon dioxide, and hydrogen by heating it in the 95% oxygen. The carbon monoxide can be reacted with the steam to produce CO2 and H2. The resulting stream is almost completely CO2 and H2, and the CO2 is easily removed prior to the combustion of H2 using a chemical solvent. Finally, CO and H2 can be fed into a turbine, burned in pure oxygen, and the CO2 separated by condensing the water vapor that is produced from the combustion of H2. Conversely, CO and H2 can be fed to a turbine, burned in the air, and the CO2 removed from the combustion. So, the process is either we can use directly to the fuel, the hydrogen can be used directly to the fuel, or we can use in the combined cycle power plant. So other method is post combustion capture, which actually we are working on this. Our team is working on this post combustion capture. So what is this method? In this method, we will allow the this normal combustion of the fuel, right? So we are supplying the fuel and the air to the boiler, and we will allow the normal combustion. So after normal combustion, you will have the constituent like carbon dioxide, nitrogen, and water, and then this exhaust gas or the flue gas is passed through some kind of a chemicals which has the greater affinity towards the carbon dioxide, and then this carbon dioxide will get captured over here, will get absorbed over here, and the remaining gases, remaining constituents are allowed to escape. And finally this carbon dioxide is again, it is again removed from this chemical agents and then compressed, dehydrated, and transported to the for some geological site. Okay, so this is the method for the post combustion capture. Here the combustion, the carbon dioxide is captured after the fuel has burnt. So what are the various ways for separating the carbon dioxide from the flue gas? So the ways are the absorption, adsorption, membrane based separation, or liquefaction. So there are some chemicals which have affinity of the carbon dioxide. So these chemicals, it is MEA. MEA is one of the common solvents which are used for this absorption process. What is MEA? MEA is monoethanol amine. Okay, ammonia is mostly these solvents are mostly ammonia based. So these have greater affinity towards CO2. So it is used in for capturing this carbon dioxide. So the absorption could be chemical or physical. So what does it mean? In the chemical, these solvents reacts with the carbon dioxide and will get another compounds. Where in the physical, like in the case of in the solvent is Celecoxole. So if we will use this, then it do not react with the carbon dioxide, do not react with this compound, and it will just get absorbed in the process. So we could use chemical or we could use physical, any solvent we could use. But Celecoxole is higher. The cost of this physical solvents are normally higher than the cost of this chemical solvents. So normally we are using the chemical solvents. The other process is adsorption. I am expecting that you know the difference between the absorption and adsorption. The adsorption is just the carbon dioxide will get absorbed on the surface only. It do not get absorbed. It is absorbed only. So there are some chemicals that we will use for adsorption. The other way to capture the carbon dioxide is the membrane-based separation. So there are some membranes which separate the carbon dioxide from the other constituents. So this is also being done. Liquefaction is also another process in which the carbon dioxide is liquefied from the other gases, and it can be separated after liquefaction. So these are the various ways by which the carbon dioxide can be separated from the other gases. Our group is only working on these absorption processes. So all the process that I described is in that process the energy is required, so that do not comes free. Okay, so if you will say that if I am using the carbon capture unit in the power plant, so the carbon dioxide will get captured without any cost. So it do not happen. Okay, so you have to give some energy in order to get success of this carbon dioxide capture. So where the energy is required, because after capturing the carbon dioxide, the solvents, the carbon dioxide should be removed from the solvents. Okay, so if you want to remove the solvent, which is called a regeneration of the solvent. Okay, so if we want to remove the solvent, so the carbon dioxide from the solvent, we need to supply some kind of heat. Okay, so some heat is required. So therefore, some energy is required to remove the carbon dioxide from the solvent. The chemical solvents require the heat. Similarly, the physical solvents also require the heat or pressure drop. Adsorbents also require the heat or pressure drop. Membrane system require electrical energy to maintain high pressure on one side of membrane. Liquefaction requires cooling the exhaust gas to as low. So, in each and every case, the energy is required. So, there is it doesn't mean that if you will put the solvent over there and you will get freely you will capture the carbon dioxide freely, so it do not happens. So other process is oxy-fuel combustion capture. So it also requires energy, because in the air separation unit, in this process we are using the oxygen. We are only using the oxygen. So using the oxygen, it means that we require air separation unit. So in this air separation unit requires high energy, because we need to separate the oxygen from the nitrogen. So it also requires energy. So oxygen is supplied to the, instead of supplying the air, we are supplying only the oxygen and the fuel. Right. So if we will combust the oxygen and the fuel, so what will we get? We will only get carbon dioxide and water. Right. And this could be separated easily, because the water vapor will get condensed, and it will be get condensed, and the carbon dioxide you will get without using any solvent. You will get the carbon dioxide from this process. So it is a very easy process, but still it requires high energy, because you need to separate the oxygen from the nitrogen. This is the basic process I'm showing here, which is normally it is used in the cement plant, and the process is called as calcium looping system. Okay. So what is this process? This is cement plant. So in the cement plant, rotary kiln is used. Probably you know the. I mean, if you don't know the process, just take it as it is. Like, there is a rotary kiln is used in the process of manufacturing cement. So after this rotary kiln, then clinker is formed, and then after cooling and some additives are mixed, and then after milling you will get the cement. So this is the process of the producing the cement. So this rotary kiln is using the fuel, and it uses the energy. So how the energy is given to this rotary kiln? The energy is given by combusting the fuel, which is normally coal. Right. So the coal is combusted, and you will get the flue gas, and the flue gas is having carbon dioxide into it. So what is done? This flue gas is now passed to one chamber. This chamber is called as carbonator. So this carbonator is basically consists of calcium oxide. Okay, and this calcium oxide is a compound which has a high affinity towards carbon dioxide. Right. This calcium oxide, when it comes in contact with carbon dioxide, you will get CaCO3. Okay, this is a famous reaction. Probably you may aware of it. So when CaO is added with CO2, you will get CaCO3. So this carbonator consists of CaO. So when the flue gas, which has carbon dioxide into it, it passed through this CaO, then this CaO will convert into CaCO3. So it will absorb the carbon dioxide, and the remaining gases are allowed to escape from this carbon dioxide. So flue gas, which consists of carbon dioxide and other gases, the carbon dioxide will get absorbed in CO, and other gases are allowed to escape. Okay, so almost 80-90% of carbon dioxide will get absorbed during this process, and remaining 10% will allow to escape to the atmosphere. So this CaCO3 now CaCO3 will happen. So now how can we convert back into CO? So it will be get converted back into CaO by transferring this CaCO3 into another chamber, which is called as calciner. Right. So what will happen? I mean, this calciner, the CaCO3 will transfer to this calciner, and now as CaO plus CO2 will form CaO3. This is the reversible reaction. Okay, so it is two-way reaction. So CaO plus CO2 will form CaCO3. Similarly, CaCO3 will form CaO and CO2 again. So what will happen when this CaCO3 is passed to this calciner? It will be heated up. Okay, so in order to reaction to take place in opposite direction, that is CaCO3 will be divided into Ca and CO2. So in order to have the reaction in opposite direction, what will we do? We have to heat this calciner. So we will heat this calciner, and then what will happen? This CaCO3 will be converted into the CaO and CO2. So this CO2 can be taken out, and the CaO can again be fed back to the carbonator. So the cycle will continue to take place. Right. So now after some duration of the time, this CaO becomes ineffective to capture the carbon dioxide. After long time of long duration, the CaO could become ineffective to capture carbon dioxide. Then what will we do? Then we have to remove this CaO. So how we will remove the CaO? CaO is removed from this calciner. So this calciner, the cement also uses CaO, right? In the production of cement, this CaO is being used. So this ineffective CaO is now passed to this rotary kiln for the production of the cement process, and the fresh CaO is bring into this calciner. So how the fresh CaO is bring into this calciner? So this CaCO3 is bring into this calciner. This CaCO3 is normally available, at our it's normal. This calcium carbonate is available in abundant quantity. So this CaCO3, after pulverizing and then heating, it will fed to this calciner. So this process will continue. So this is the process of capturing the carbon dioxide and then separating the carbon dioxide from this calcium carbonate. Right. So this carbon dioxide is then compressed and then transported to some geological site. So what are the problems with this carbon capture and storage system? High price of installing carbon capture system. So why it is not still it is in the developing phase, or why still it is not being implemented? So the implementation requires high price of installation of the carbon capture system. Capturing carbon dioxide requires much energy. As I said that you will require energy at various places to capture this carbon dioxide. It do not comes free, right? So it requires energy, and this energy is called as energy penalty. Risk of leakage and collateral damage to storage media, geological formation, and if you are storing it into some geological sites, leakages could happen. Right, so these things also there. Increment in cost of energy production. So because it do not comes free, so therefore the energy production cost will increase. So these are some problems, and the research has been going on, and probably maybe in few decades we will come out with the problems. So now I'm talking about what we are doing at IIT now. So what we had done and what we are doing. So first, what we had done. First of all, as I said, that it is it is a very costly process. So first of all, we will take out the techno-economic assessment, that what will be the cost of this implementing this carbon capture unit. So we have taken some data from this Wangbori thermal power station, Gujarat State Electricity Corporation, Wangbori, Gujarat. So the power plant data is taken from this organization, and then we have used this software. This is open software, so one can download the software free. This software is integrated environmental control model. In the short form, it is called as IECM software. So this software is developed by the Mellon University, United States, and therefore it will give you the data in dollars, in the US dollars. Right. So we have used this software in order to get the assessment of the cost associated with this implementation of this carbon capture and storage. So these are the results that we had obtained through the software. So for 210 megawatt of power generation, the carbon dioxide emitted is without carbon dioxide capture is 1.12, and with CO2 capture is this much. So this much carbon dioxide has been captured, and cost of electricity in dollars comes out to be somewhere around 91. So earlier it was 53, now it is $91. So from the results, we have concluded that somewhere around 5.7 rupees per kilowatt hour, uh, it will be added if we will implement this carbon capture unit to this power plant, to this particular power plant, Wangpori power plant. So if we will implement this carbon capture storage into this Wangpori power plant, this much cost will be added into our into the electricity bill. So which is a huge amount. 1 kilowatt hour means that is only 1 unit. So 1 unit, the cost of 1 unit is probably it is somewhere around 3 or 4. But if the cost comes double, so it will be a very huge amount. But we have not considered the carbon dioxide that have been captured from here. So this carbon dioxide can be utilized for other purposes also. So this carbon dioxide can also be sold off. So in that way, the cost could be reduced if we if we sell some carbon dioxide which had been captured. So then cost will definitely be reduced, right? And like the stored carbon dioxide can be reused in various application, or it can be sold to industries like chemical industry, the fish industry, and so on. So that analysis we had not done, but that could be done, and then the cost could be different. We also have published one patent. This patent is associated with the diesel engine. Okay, so normally most of the research work has already been conducted on the power plants, cement industries, right? But the research work on the diesel engine or the petrol engine are very less or very few. So therefore we had conceptualized this idea that why don't we use this carbon capture unit into a diesel engine, right? So this carbon capture unit is can be implemented in this diesel engine. So how can we implement this? Suppose this is a cylinder, this is the intake, and this is the exhaust. Okay, one is intake and 3 is exhaust. So in the from the exhaust you will have exhaust gas which contains the carbon dioxide. So this carbon dioxide is given to this 4, which is heat exchanger. So after cooling the exhaust gases, it is passed to the 5. 5 is what? 5 is EGR valve. So this diesel engine has the exhaust gas recirculation. So what is the exhaust gas recirculation? Exhaust gas recirculation is a process where the NOx amount is reduced. Okay, NOx is also a very harmful emissions that are coming out from the diesel engine. So that NOx emissions could also be reduced by using EGR. Okay, so EGR is used to reduce the NOx amount. So this is the EGR valve. In this EGR process, which is called as exhaust gas recirculation. So what is this? In this, the part of the exhaust gas is recirculated back into the intake manifold. Okay, so by doing this, you can reduce the NOx emission. So there is a separate theory. So this NOx emission can be reduced if we supply the part of the exhaust gas into the diesel. But if you supply the exhaust gas, part of the exhaust gas into this diesel engine, the carbon dioxide amount will get increased. So you will get more carbon dioxide. So what will we do? We will supply this carbon dioxide to this carbon capture unit. So this is the carbon capture unit. So this carbon dioxide exhaust gas is supplied to this carbon capture unit, and which capture the carbon dioxide. It contains some solvent, and which capture the carbon dioxide, right? And this captured carbon dioxide is now be released to the atmosphere, right? So this is in this exhaust is 8, so it could be released in the atmosphere. And then this solvent is again, after delivering the carbon dioxide back, it will be again circulated back into this carbon capture unit. And finally, this carbon dioxide is, it is stored somewhere in the engine itself, and it could be stored somewhere at some location. So this is the patent which is published in the Indian patent uh, publication. Uh, the reference is given here. So we have done further study on this patent. So what we have done, we had conducted some ANSYS simulation for this EGR process, exhaust gas recirculation process. So ANSYS simulation has given some results. The results that we had found that without exhaust gas recirculation, you will see the temperature very high, but with 10% exhaust gas recirculation, 20% exhaust gas recirculation, 30% exhaust gas recirculation, the temperature will drop down. So because of this drop down of the temperature, the NOx emissions will get reduced. Because the formation of the NOx will require the high temperature and the ample quantity of the oxygen. So if you are supplying the exhaust gas instead of supplying the oxygen part of the exhaust gas, then what will happen? The oxygen quantity will get reduced into the engine cylinder, as well as the temperature is also reduced. So because of the reduction of the temperature will reduces the NOx amount. Okay, I think, I hope that this procedure you must know the exhaust gas recirculation, so I'm not going into much detail into this process. So this graph will shows you that this is the without EGR, and then this 10%, 20%, 30%. So if you are supplying 10% of exhaust gas back into the engine, the NOx amount has reduced. Okay, so you will see for 30% exhaust gas recirculation, the NOx amount is lower than without EGR. Okay, so the combustion is taking place after this crank angle. So this is prior to the combustion. So prior to the combustion, without EGR there is no NOx. But if you are supplying 10%, 20%, 30% EGR, so obviously the NOx amount is more prior to the combustion. But after the combustion, the NOx amount is higher without EGR, and with EGR the NOx amount is lower. But the other problem with EGR is that CO2 is increasing. So you will see the CO2 is increasing with 30% EGR, where the CO2 is having a less amount without recirculation. So reducing the NOx amount has drawback that CO2 will get increased. So therefore the CO2 has to be captured. We had performed one experiment on the engine test rig. So this is the engine test rig which is available at our institute in the IC engine lab facility. This engine is available. So we had conducted some experiments on it. We have all the facilities like measurement of smoke and measurement of the exhaust emissions. So this is the schematic of experimental setup. You will see this is the engine, this is the exhaust pipe of the engine, and this is the exhaust manifold. And from this exhaust manifold, this is the carbon capture unit we had installed. And in this carbon capture unit, we have analyzed the gas prior to this carbon capture and after this carbon capture. Okay, by using the gas analyzer. So by using the gas analyzer, we had done this analysis the gas. So what we had found, so without capture, earlier the carbon oxide was, by percent of the volume. This is the carbon oxide at various break power. Okay, so 0.37 break power. This is the carbon oxide percentage. At 0.57 break power, this is the carbon oxide percentage. At 1.17, this is the carbon oxide percentage. Without capture. With capture, you will see the carbon oxide percentage has reduced drastically. You will see the carbon oxide percentage has reduced drastically with capture. So we have used the solvent ammonia. Now ammonia is a solvent which is cheaper. That's why this is the reason why we have used ammonia. But the problem with the ammonia is that it is also very highly toxic, right? It is highly toxic and volatile also at the room temperature. Therefore, we have used this ammonia at lower temperatures. So basically, we have used this ammonia at somewhere around 5 degrees centigrade temperature. Right, so because if we use the ammonia at high temperatures, it generates the fumes which could be dangerous. So this was the one of the this is the one of the research that we are doing in this at our institute. The other research uh, is on this chemical looping combustion. So what is this chemical looping combustion? This chemical looping combustion is another method to capture the carbon oxide. It is also a it is recently developed method to capture the carbon oxide, and it is also having a is a low energy penalty. That is, uh, compared to the other methods, it is most cost effective. So what is the method? The method is, in this case also you have a two chambers. One chamber is called as air reactor, other chamber is called as fuel reactor. So in the air reactor, some metal particles are kept, right? These metal particles, the metal particles that are kept are having the carbon affinity, okay, carbon oxide affinity. So like ferrite, okay. So the ferrite, if you will use ferrite over here, so this ferrite is having this carbon dioxide affinity, and this carbon oxide molecules will get attached with this ferrite molecule when the uh, when we supply the exhaust gas over here. So this carbon oxide particles, this carbon oxide molecules will get attached with this particles, right? So this now this ferrite particles contain the carbon oxide particles and now transferred to this fuel reactor. Sorry, not carbon oxide, oxygen. I'm sorry. This we are using ferrite material which has greater affinity towards oxygen. Okay. So what will we do if we will supply the air to this chamber? So this oxygen particle will get attached with this ferrite, and this ferrite and oxygen particle will be sent combustion uh, to this combustion chamber, to the fuel reactor, right? So what will happen over here? This ferrite particle with oxygen, this oxygen is now detached from this ferrite particle because this chamber is highly heated up. It is a combustion chamber, so therefore it is highly heated up. It contains the coal particles or other fuel particles which we want to burn. So this oxygen will get separated from this solid particles, and then this oxygen when this coal or fuel particles come into the contact of this oxygen, they will get burned. Okay, so because we are only supplying the oxygen, so therefore you will get only the two constituent in the exhaust gas. One is CO2 and another one is the H2. So with the CO2 and H2O, it will be get condensed, and then you will only get the CO2, and which will get easily captured. So therefore you will see this process is highly cost effective because you do not require any kind of air separation unit. So oxygen is only carried by particles. So these particles are called as oxygen carriers. Okay, so these are the particles which are termed as oxygen carriers. So what does this particles will do? This particle will take the oxygen, and then it will take the oxygen to the another chamber, and here it releases the oxygen and the combustion will take place, and finally the particles will again send back to this chamber. So in this way the cycle will get continued, and you will have that this exhaust gas contains only carbon oxide and the water vapor. The water vapor will get condensed and you will only have a carbon oxide. So there is no solvent is required. There is no solvent required. There is no air separation unit required. So therefore, this is a highly cost-effective method. So we are working on it. We are basically doing a simulation on this air reactor and the fuel reactor. So you will see that here the air is supplied into this air reactor. Okay, there are some particles into this air reactor, and we are supplying the air. Air is a fluid, and the particles are in the solid phase. So therefore, we are doing the modeling, and the modeling that we are doing is the multi-phase modeling, right? So why it is multi-phase modeling? Because there are two phases present in this chamber. What are those two phases? One is air, which is in the fluid state, and another one is this particle, which are in the solid state, right? So these particles are actually suspended into this air. So therefore, these particles behave in the liquid fashion only. So which is called as fluidized bed reactor. So it is a kind of a fluidized bed reactor. So there are few things more. How much time do I have? Or should I conclude?
So I think 2:30, and Our time is 1:30 to 2:30, and you can continue, sir. Don't worry.
Okay. Uh, I mean, not much cement, but yeah, these are the we are doing the CFD simulation on into this multi-phase modeling. So these are the chemical looping features already defined. So I'm just skipping this slide. So we are doing this CFD simulation. In this CFD simulation, because there are two phases, one is air and one is solid particle. So there are two phases are present. So therefore, multi-phase modeling uh, is multi-phase modeling is required for simulating the this air reactor and the fuel reactors. So normally in the fluid mechanics course, you know that the two approaches for the fluid. One is Lagrangian approach and the Eulerian approach. Lagrangian approach is the particle-based approach in which all the particles are tracked during its flow, and the changes in the properties are identified for each particle, and then the time rate of change of the property is defined in such a way. Whereas in the case of the Eulerian approach, a fixed location is identified, and at this fixed location, as the fluid is flowing at this fixed location, the time rate of the property change is measured, and then it is averaged over the whole control volume. So these are the two approaches. One is the Lagrangian approach and Eulerian approach in the fluid mechanics for a single phase flow. But in the case of this air reactor, fuel reactor, we have a multi-phase flow. Okay. So in this multi-phase flow, these are the three approaches that we are using that could be used. One is Eulerian Lagrangian approach, where Eulerian approach is used for the air, which is a fluid, and Lagrangian approach is used for the solid particles. In the Eulerian approach, in which the Eulerian approach is used for the fluid as well as for the particle both. Okay. This is the approach that we are using, and it is a common to use this approach, which is called as volume of the fluid approach. So in this approach, volume of the fluid approach, the Eulerian framework for both the fluids are both the phases are used with a specialized interface treatment. So there is a long theory of all these approaches. So it's a semester course for this multi-phase flow. So these are few of the publications, and these are some of the references. Thank you. So that's all from my side. If you have any questions, I'm happy to answer.
Okay, thank you very much, sir, for sharing knowledge on the post-carbon capture technology. And now we have 5 minutes for any questions related to our topics. So kindly note down my number, and you can send me on my WhatsApp number. Please note down my number 7878 6061. Once again, I repeat my number 7878 6061. So, sir, we are waiting for a few minutes. So, if anyone have any questions or query, then I will ask to solve their problems. Uh, Hello, sir.
Yes, any questions?
Sir, there is two, three questions related to our topics. So someone asked me if carbon captured in a specific structures and we have to store in a earth. So
Yeah.
their effects on their environmental and the life around that location.
I don't think because it is stored deeper into the earth, okay, and it is stored in that site where as I said, as I have mentioned in the too, that the rock forms the seal. Rock form the seal, and these rocks are actually impermeable to this carbon dioxide. It do not allow the carbon dioxide to come back to the atmosphere. But yes, I mean, if it is coming back to the atmosphere, it is there is no harm because carbon dioxide is not a harmful for the human beings. It is only creating the problem of global warming, right? So it is as such there are no health effects on of the carbon dioxide. So there is actually not a problem for the health on the health of any human beings or animals.
Okay. And the second question, sir, any criteria for the selection for store the carbon capture?
Any criteria for selecting the
Earth is space in the on the Earth for the store the carbon.
criteria? Yeah, I mean, we have to determine that whether the reservoir is available in the deeper into the earth, or we have a seal rocks that could seal the carbon dioxide so that it could not come, the carbon dioxide could be stored for the longer years. So that is the main criteria, and that's why I said that where the carbon dioxide is captured, you cannot store directly into over there. You cannot directly bore the earth over there and inject the carbon dioxide because it will come back to the atmosphere again. So therefore, you have to survey the location. It could be onshore, it could be offshore. Okay, so you could survey the location first, and you will determine that whether this is the suitable site for the carbon dioxide storage. So therefore, there are so many challenges also, and that is there.
Okay, sir. And one more question, sir. In India, where we have to store the carbon capture,
Yeah,
any
I
specific area in
yeah
India?
I think in Maharashtra the Indian oil refinery site. This program is actually it was in pipeline, but I don't know the progress of that program. They are actually they found the site where the carbon dioxide could get stored, but I don't know the progress of that, and I don't remember exactly where the location of exactly where it is in Maharashtra. You can Google it and you will find. Definitely, you will get. I'm aware of this one program, but exactly I could not, trace it.
Okay. And sir, one last question, sir. Someone heard about the carbon credit in a newspaper. So can you, sir, explain what is the meaning of the carbon credit?
Yeah, carbon credit actually, because in the developed countries, most of the industries are using this coal or other fuels to generate the electricity or for other purposes. Okay, so they are releasing the carbon dioxide into the atmosphere. So those countries have, the government has imposed the penalty on those industries, which are generating the carbon, which are generating the carbon dioxide at a very high amount. So there is some dollars penalty is it is given to these industries. I don't know the exact figure. So what they will do, what the industries will do, the industries will capture this carbon dioxide, and then they will say that okay, we are using it. Sorry.
Okay.
So they are capturing this carbon dioxide, and then what they will do, they will they say that okay, we are not exposing it to atmosphere, so we are storing this carbon dioxide. So that is what is called as carbon credits, and then they will get the carbon credit of this. Okay, so that is capturing the carbon dioxide. It is our term is carbon credit. So if they are using the renewable energy, suppose instead of using the coal, if they are using the renewable energy, so if they use the coal, this much of carbon dioxide they will emit, and if they're using renewable energy, then this much of, so this much of carbon dioxide they could save. So the carbon dioxide save is nothing but the carbon credit. So this is another way to define this carbon credit.
Okay, okay, sir. Thank you very much, sir. Once again, I heartily thanks to you for accepting our invitations and share the knowledge on the carbon capture technology. Uh, Thank you very much. And also, I would like to express my sincere thanks to all of you who sincerely attend these knowledgeable webinars and make it a success. Thank you very much, all of you. Have a good day. Thank you, sir.
Yes, thank you.
Okay,
Thank you.
thank you.
Thank you.
Okay.
Should I leave?
Yes, sir. Yes, sir.
No.
Sir, our session was completed.